Let us see about Schottky barrier diode, Zener diode and Varactor diode. Here, while we are seeing this, here first one is the Schottky barrier diode. That is, in recent years, there has been increased interest in two terminal device referred to as a Schottky barrier, surface barrier, or hot carrier diode. Its areas of application were first limited to very high frequency range due to its quick response time and the lower noise figure. However, it is appearing more and more in low voltage, high current power supplies and AC to DC converters. And here, if you are going for this construction, it is quite different from the conventional PN junction diode. That is, the metal semiconductor junction is created and is shown in the figure. The semiconductor is normally a N-type semiconductor with a lot of different metals such as molybdenum, platinum, chrome and tungsten are used. Different construction techniques will result in a different set of characteristics for the device, and such a increased frequency range, lower biased forward bias and so on, and the priorities do not permit an examination of each technique here, but the information will usually be provided by the manufacturer. And here, Schottky diode result in a more uniform junction region and a high level of ruggedness. In both materials, the electrons in the majority carriers. In the metals, the level of majority carriers is insufficient, and when the metals are joined, the electrons in the N-type silicon semiconductor material immediately flow into the adjoining metal, establishing a heavy flow of majority carriers. Since the injected carriers have a very high kinetic energy level compared to the electrons of the metal, they are commonly called hot carriers. And in addition to that, the metal establish a negative wall in the metal at the boundary between the two materials, and the net result in the surface barrier between the two metals, preventing any further circuit. And that is any electrons in the silicon material face and carrier free region and a negative walls at the surface of the material. That's about the Schottky diode. While we are seeing this Zener diode, this is the symbol, and here the Zener diode, it is a type of diode that permits current not only in the forward direction but it is in the normal diode, but also in the reverse direction. If the voltage is larger than the breakdown voltage, called as the Zener voltage or Zener voltage, and the device was named after Clarence Zener, who discovered this electrical property. And while here we are saying this breakdown diode, this basically the same as the standard PN junction diode, but they are specifically designed to have a low predetermined revised breakdown voltage and takes advantage of this high reverse voltage, and the point at which the Zener diode breaks down or conducts is called the Zener voltage. And the Zener diode is like a general purpose single diode consisting of a silicon PN junction which bias in the forward direction, and it behaves just like a normal signal diode passing the rated current. But when the reverse voltage is applied to its reverse saturation current remains fairly constant over a wide range of voltages, and the reverse voltage increases until the diode's breakdown voltages is reached, at which the point a process called avalanche breakdown occurs in the depletion layer, and the current flowing through the Zener diode increases. And here the point at which the current flows can be very accurately controlled in the doping stage of the diode's construction, giving the diode a specific Zener breakdown voltage ranging from a few volts up to a few hundred volts. And this Zener breakdown voltage on the IP and the IV curve is like the vertical straight line. While we are going for this characteristics, here this is the characteristics. The Zener diode, the reverse bias or reverse breakdown voltage, that is the diode connects, anode connects to the negative supply. From an IV characteristics current above, we can see that the Zener diode has a region in its reverse bias characteristics of which a constant negative voltage regardless of the value of the current flowing through the diode, and remains nearly constant even with large changes in current, as long as the Zener diode remains between the breakdown region and the maximum current region. And here next one is the Zener diode regulator. Here, while the Zener diode can be used as a used to produce a stabilized voltage output with low ripple under very load current condition by passing a small current through the diode from the diode source via the suitable current limiting resistance. And also here, while we are seeing this, that is the DC output voltage from the half to or full wave rectifiers contains ripple superimposed onto the DC voltage, and that as the load value changes so as to does the average output voltage. By connecting a simple Zener stabilized current as shown between across the output of the rectifier, a small output voltage can be produced. Next one, the Varactor diode. While we are going for this is the Varactor diode. It is the thickness of the depletion in depletion region is the variable dielectric. The diode is placed in reverse bias and the dielectric is adjusted by reverse bias condition. And here the junction capacitance is present in all reverse bias condition because of the depletion region. Junction capacitance is optimized in a Varactor diode and it is used for high frequency and switching applications. And also the Varactor diodes are often used for electronic tuning application in FM radios and also in televisions. Here, while we are seeing this is also known as variable voltage capacitance diode. That is, the junction acts as a variable capacitance under the changing reverse bias and it is known as the Varactor diode. Here, the Varactor diode is specially constructed of high resistance under reverse bias condition. For Varactor diode, and it is given by CT equal to epsilon A by W omega D. That is, already given in this equation. That is, CT is the total capacitance of the junction and epsilon is the permittivity of the semiconductor materials and A is the cross section area of the junction. WD is the width of the depletion layer and the curve between the reverse bias voltage across the Varactor diode and the junction, and the total junction capacitance can be changed by changing this VR. Thank you.